liners, thank you very much for your company. Welcome back to the channel Transmission Lines Engineering TV. So far we have explored the documentation generated by each of the participating disciplines in the design and construction of a transmission line. Now we will talk about a topic which in my opinion is overlooked and unfortunately lacks of a culture of documentary organization. I'm referring to the way in which we use our computers to archive the information generated in an orderly manner with an easy access and identification, but above all, in a uniform way. The way in which we store our information is basically very similar to the one used prior to the existence of computers in physical folders, but nowadays these so bulky binder systems, which occupy large spaces in offices and over time were sent to the dead archive, has been replaced by virtual or electronic folder system in our computer's network. Personally, I still had to work with these systems not many years ago in such a way that when we require some information from an old project, we had to go to the graveyard, to the dead archive to play the role of Dr. Frankenstein and revive dead projects to find the information that we require. This was a tedious process, tired because the coffins or boxes were quite heavy and it was an endless numbers of boxes to search on. Nowadays, and despite the massive use of computers, this type of search I see still persists, but in a different and even more complex way. Looking for the information in one and another electronic folders on occasions becomes a true headache, especially because creating folders on computers is accessible to everyone at any time under each person criteria who has access to the networks. How many times have happened to you that you need to look for some information and you search in another folder and you don't find it until somebody suddenly comes up and tells you that they found the information and it was located in another folder in a chain of subfolders so well stored that nobody could find it. That's what this video is all about. I'll try to offer you a system of creation and administration of virtual folders, which in my experience has given me good results. It's not something infallible, but at least it could make a bit of order in our information stored in computer networks. It's not the best, not the worst, but I saw the importance of making this video about this topic and decided to share it with you, hoping that it will be helpful for you. It's going to be a long video, please have me patience, but I'm sure it's going to be really helpful for you. So let's get started. Previously, we have described the participating areas and the basic documentation that each discipline will develop. That's the importance of all the previous videos to understand the administration of the project before getting into technical topics. So the areas involved, as we mentioned before, are number one, engineering, which has the subdisciplines of transmission lines engineering and substations engineering. Number two, we have construction. 3, procurement. Number 4, contracts administration. Number 5, environment. Number 6, quality. 7, permission management. Number 8, project management. And 9, last but not least, bids. If a folder is created for each area, it can be a good point to start, and if we have identified the activities and documentations of each discipline, it will give us a guide to manage our folders. So let's see how it works. Let's suppose that our imaginary project is a 400 kV line double circuit which will be connected to another line to have a tap to another substation. The main line is called San Rondel 2, which departs from the San Rondel substation to feed the Rondel 2 substation. A circuit will be routed from substation to substation, while the other will have a deviation or tap to another substation called Rondel Herco Power. The name of our project at the end, it will be transmission line San Rondel 2 junction Rondel Herco Power, with project code LT for transmission line, SR San Rondel, R2 Rondel 2, RHP Rondel Herco Power. For this project, which is a 300 kV line, the client has requested a phasing transposition and installation of interface spacers. So let's see how we could organize our folders to organize this information. In our network drive, let's suppose W drive, we will start creating the folders for the project. So in the W drive we have the folder San Rondel 2 junction Rondel Herco Power with its corresponding code. The discipline which we will develop in detail is the transmission lines engineering area, but for the remaining disciplines I have developed a very general way, since I'm not specialist in those areas, but they could serve as a guide. So within each folder of each document to be generated, there will be a subfolder called superseded, which will serve to deposit in it those documents that are not valid, or as the name indicates, have been superseded by a new revision. In this way, two activities are controlled at once. Number one, the history of each document is monitored by a single folder, and number two, there is a direct access to the folder where the ultimate or the revision in effect is the only one and exclusively stored, to avoid looking in other folders or enter into a single folder to track the latest version. I really recommend you this folders organization to improve control in the electronic information. It has given me really very good results. So we have the folder San Rondel 2 junction Rondel Herco Power, and the subfolders for these disciplines. The first one, engineering, in which we have two subfolders. We will talk about the transmission lines engineering. Inside this one we have the first one, trajectory, and inside the trajectory we have different activities. We have the right-of-way calculation and the superseded folder in case we need to make new revisions. Getting back, we have the GIS coordinates and superseded folders. Again, next one, we have the staking drawings, superseded folder. Access roads drawings and superseded. Getting back, temporary working spaces drawings and superseded. Getting back, alignment drawings and superseded. Now, getting back further, we have the number 2 document, cables mechanical calculation and superseded folder. Document number 3, plan and profile drawings, superseded. Number 4, Substations connections drawings, superseded. Number 5, facing drawings, superseded folder. Number 6, phase transposition drawings, again superseded. Number 7, structures list, superseded. Number 8, materials general list, I mean for purchases, not for construction, and superseded. Number 9, we have the structures air gaps drawings, and inside this one, since we have different types of structures, we have the first one, suspension structures, and superseded. Next one, tension structures, superseded. And third, we have transposition structures and superseded. In that way, we are able to monitor each type of structure with its corresponding drawing. Number 10, structures drawings. And again, we have different types of structures: suspension, superseded; tension structures, superseded; transposition structures, and superseded. Number 11, grounding drawings and superseded. Number 12, signaling drawings. And again, we have different kind of crossings. We have railways with the superseded drawing, highways, superseded; river crossings, superseded; airports, superseded; and pipelines, superseded. Number 13, we have arms distribution and superseded. Number 14, OPGW engineering, in which we have different activities. The first one, we have the splice boxes location and superseded. It always happens that you dictate where are going to be located the splice boxes for the OPGW, and suddenly the reels are mixed, and then you have to change the location of the splice boxes. So you have to be very, very careful how you distribute these boxes, and very good control of this information. Next one, we have OPGW assembly drawings and superseded. We have suspensions, tangents with or without splicings, dead ends, etc. Number 15, structures shop drawings, in which we have shop drawings and superseded. We have assembly drawings and superseded. Number 16, we have poles shop drawings. Inside this one, we have the assembly drawings and the superseded folder. Number 17, dampers engineering. We have activities inside this one. We have first one, the dampers study and the superseded. Getting back, we have the dampers distribution document and superseded folder. Number 18, interface spacers engineering. Again, we have two activities. We have the interface spacer study and the superseded, interface spacer drawings, superseded, and 19, material distribution. This time is for construction, not for purchases, in which we have the superseded folder. Number 20, sag and tension data. We have different cables. The first one, conductor cable, superseded; overhead shield wire, superseded; OPGW, superseded. Number 21, materials technical sheets for each material and the superseded. Number 22, counterweights calculations in case we need them, superseded. Number 23, hardware balancing and compression in case it is required, superseded. Number 24, we have the new design structures. Let's suppose that this project includes into its scope the design of completely brand new structures for suspension, dead ends and transposition. So we have lattice towers where we have the subfolder for basic design and the superseded folder. We have as well the design review folder and the prototype test folder. As well, we need in this project steel poles where we have again basic design folder with superseded, design review, and number 25 we have foundations. And inside the foundations folder we have different activities such as the geotechnical study, and inside we have some other subfolders for the scope of work and the superseded, and of course the folder related to the geotechnical report and the superseded. We need as well another folder for foundations, this time for towers, and again we have another subfolder for the design criteria of the foundations, another folder for calculations document, superseded, and the corresponding foundation drawings along with the superseded folder. In addition of lattice towers we have steel poles, and again we have the design criteria for steel poles and superseded, the calculation document, superseded folder, and foundation drawings for steel poles and superseded. Now getting back at the very beginning, we have, in addition of the transmission lines discipline, we have the substations engineering folder. This folder, of course, I didn't create nothing, but it can be used in the same way to define the activities, the documents related to substations, so our fellow substations designers can use the same structure to organize their very own information. Now getting back to another discipline, construction. In construction, well, I made some few folders as an example. We have the construction schedule, meeting minutes, construction binnacle, warehouse control, and access roads. Another discipline, procurement. In procurement we have the purchase plan, another folder for the supply of structures, where we have the quotations folder, quotations technical evaluation, and purchase order. Another material, cables, same structures, quotations, quotations technical evaluations, and purchase order. Hardware, same structure. OPGW, same structure. Grounding materials, again, same one. Signaling materials, we have painting, where we will have the same structure. Marker balls, same structures, quotations, technical evaluation, and purchase orders. We need the dampers, same. Interface spacers, same structures. And we have the next one, contracts administration, where we could have client contract, construction contract, warehouse contract, and maybe union contracts. Next discipline, environment. We have maybe archaeological zones or protected environmental areas. We have the next discipline, quality. Inside this one we have different folders. The first one, the client specifications, where we can compile all the applicable specifications for this project, so everybody can go to one single place to consult any specifications for purchases, for engineering, or for construction. We have another folder for internal specifications. Many companies internally they have their very own design specifications or purchases specifications as well, or procedures basically. We have the quality formats, inspection test plan, ITP, purchases quality plan, and of course the as-built package. Next discipline, permits management. In permits management, remember that we have different types of crossing in the transmission line. We have railways, where we have the application to the third-party agency and the approved drawing. So we have a folder for each one. We have highway crossings, application and approved drawing. River crossings, same. Airports, same. Pipelines, same structure. Now let's go to the discipline of project management, where we could have folders for cash flow, scheduling, expenses management, commissioning, contractors management, and minutes management. And last but not least, we have the discipline of bids, where we have folders for bids quantities, scheduling, supply schedule, and budget schedule. The folders organization on a computer does not stop with just creating the folders and have the uniform structure for each project, but it is very important to have a process of how to name the electronic files of each document. It is very common that the same document with the same content appears more than once or twice in our computers, and even worse, with different names in the electronic file. This must be controlled to avoid confusions, information duplicity, but above all, create a uniformity of how to name the electronic files depending on the type of the documents, say a calculation or a drawing, a purchase order, a contract, whatever it is, and its content. So next, we will describe a way that has also given me good results, and I'm sure it will be helpful for you as well. We have several types of documents. We have calculation documents, we have drawings, documents such as calculations data, explanatory documents, materials technical evaluations, contracts documents, or construction scope of work or material supply. In the case of transmission line engineering documentation, a code will be assigned to each type of document, which will be preceded by the project code in question, and at the end it will be added the revision of the document. So let's see now for line documents how to build the name of each electronic file based on the aforementioned format with the following syntax. We have first the project code, followed by the area, which will be lines or substations. Then we have the document type, a drawing, a calculation, whatever it is. And then we have a consecutive number. And at the end, the revision of that document. Now, we will assign a code for each document type. So please be patient with me. So it's going to be a bit long, but trust me, it is really necessary and it will be helpful for you. So let's see how it works. The right-of-way calculations will have a code RWC, right-of-way calculation. Coordinates table, code XYZ. Staking location drawing, code SLD. Access road drawings, ARD. Temporary working space drawing, code TWT. Line alignment drawing, code LAD. Cables mechanical calculation, code CMC. Structures location, plan and profile drawings, code PPP. Substation connection drawing, code SCD. Facing drawing, code LPD. Phase transposition drawing, PTD. Structures distribution list, SLL. Materials list purchase, code MLP. Structures electrical drawings, SED. Hardware assembly drawing, HAD. Grounding assembly drawing, code GAD. Crossing and signaling drawing, code CSD. Arms distribution, code ARD. OPGW engineering, OFE. Tower short drawings, code TSD. This will be depending on the manufacturer's nomenclature. Tower assembly drawing, code TAD, same depending on manufacturer's nomenclature. Steel pole assembly drawing, code SAD, same depending on manufacturer. Dampers distribution document, code DDD. Interface spacer document, ISD. Materials distribution list, code MDL. Sag and tension chart, STC. Materials technical sheets, code MTS. Counterweights, CWT. Balancing and compression calculations, code BCC. Tower basic drawings, code TBD. Steel pole basic design, SBD. Geotechnical study report, GSR. Foundation calculation document, FCD. Foundation drawing, FDD. So now let's apply these codes, taking as an example the structure location drawings and assuming that we have 45 drawings. So we have the syntaxes: project code, area, lines of substations, document type, consecutive number, and revision. In the case of the location drawings for structures, we have the project code, transmission lines, the code for transmission lines, PPP, which is the code for structure location drawings, 01, which is page or sheet number 1, revision 1, and then sheet number 2, sheet number 3, each one on revision 1, and all the way down to page number 45, revision 1. In this way, 3 things are achieved. Number 1, the folder structure for any project is standardized. Second, the way of naming the electronic files is standardized, making a differentiation between them by the aforementioned syntax. And number 3, new revisions can be generated to each sheet or page and sent to the previous version to the superseded folder, and keep all the most updated information handy and visible for everyone, keeping a history of each drawing. As an example, let's suppose that page number 1 is in revision 3 and page number 3 is in revision 2. So the current folder will look like this. We have the page number 1 in revision 3, page number 2 is in revision 1, and page number 3 is in revision 2, and all the way down to page 45, revision 1. So in the folder corresponding to superseded, we keep the revisions 1 and 2 of page number 1 and revision 1 of page number 3. So we have superseded folder and page 1 and 2, revision 1, and page 3, revision 1. So at the end, with these folder systems and electronic file naming, they can be extended to any type of document and all disciplines, and have an easy and fast access to the most recent information, but above all, in a uniform way for every project and to all members of each discipline. In the next video, we will see how to generate another very important topic, which you will have even more control on the generated information. I mean to the master documents list. I hope this way of managing the information has been helpful. The objective, as always, is to provide you with information that will help you for your transmission line projects, including not only the engineering area, but also the associated disciplines as well. Thank you very much, liners, for your kind visit. Don't forget to subscribe and leave your comments on this one. So until next video, Transmission Lines Engineering TV, training to power the world.